Hello, everyone. Welcome to AI Learning Podcast. I'm James, your host for today, and I'm thrilled to have you all here. This podcast is all about diving deep into the fascinating world of artificial intelligence, breaking down complex concepts, and exploring how AI is shaping the future. Whether you're an AI enthusiast, a tech professional, or just curious about the potential of these technologies, there's something here for you. Today we're talking about deep learning, one of the core areas driving the power behind AI. And I'm joined by someone who brings incredible insights to every episode, our co-host, Ethan.
Thanks, James. Hi, everyone. I'm Ethan, and I'm excited to be here today. My background is in machine learning, and I've been fascinated with how AI is transforming industries and everyday life. In this podcast, James and I explore both the basics and cutting-edge developments in AI, aiming to make it accessible and engaging for everyone listening. So let's dive into today's topic, exploring the amazing world of deep learning.
Let's start with the basics. What exactly is deep learning? Well, to put it simply, deep learning is a specialized branch of machine learning that uses structures called neural networks, which are somewhat inspired by the human brain. These networks consist of layers of algorithms that process data in increasingly complex ways. Deep learning models can learn to recognize patterns and make decisions, which makes them ideal for tasks like recognizing images, translating languages, or even driving cars. Essentially, deep learning is all about creating systems that can analyze vast amounts of data and find meaningful insights within it.
Exactly, and it's interesting to note the difference between deep learning and traditional machine learning. Traditional machine learning often relies on specific features and rules defined by humans. So, if we were trying to teach a machine to recognize cats in photos, for example, we might program it to look for features like fur, whiskers, and pointed ears. But deep learning doesn't rely on specific rules like that. Instead, it learns to recognize these features on its own by analyzing huge amounts of data. This makes deep learning much more adaptable, especially in cases where human-defined rules might fall short.
That's a great point, Ethan. And this adaptability is why deep learning has become such a significant force in AI. Unlike traditional machine learning, deep learning can handle a level of complexity that's necessary for things like self-driving cars, speech recognition, and even medical diagnoses. It's also why we see deep learning models getting more accurate and powerful as they are exposed to larger data sets. This has allowed deep learning to drive some of the biggest breakthroughs in AI, enabling machines to understand and respond to data in ways that were previously unimaginable. Now that we have a sense of what deep learning is, let's talk about why it matters so much in our world today. One of the most impactful areas where deep learning is used is in image recognition. Think about how your phone can recognize your face and unlock itself. That's deep learning at work. It's also behind things like identifying objects in photos, which helps in everything from medical imaging, where it can assist in spotting diseases, to self-driving cars that need to detect pedestrians, traffic signs, and other vehicles in real time. Another big application is in natural language processing, or NLP. This is what allows AI to understand and respond to human language. So, when you ask Siri or Google Assistant a question, deep learning is what makes it possible for them to interpret and respond accurately.
Exactly, James. And deep learning has become embedded in so much of the technology we interact with daily. Take our smartphones, for instance. When your phone suggests words while you're typing, or can even predict what you're about to say next, that's deep learning making communication smoother. Or consider how your smartphone camera can enhance images by detecting faces, adjusting lighting, and even recognizing certain scenes. It's incredible how much deep learning has improved our experience with these devices. Then we have smart home devices like Alexa and Google Home. These devices use deep learning to understand our voices, even with background noise or accents, and they keep learning to get better at understanding us over time. Deep learning has really taken these technologies to a whole new level by making them more responsive and personalized.
Absolutely, and we're only scratching the surface of what deep learning can do. Industries like healthcare are using it for early disease detection, analyzing patient data, and even helping doctors make better treatment decisions. In finance, Deep learning is used to detect fraud by recognizing unusual patterns in transactions. Even the entertainment industry is getting involved, with platforms like Netflix using it to recommend shows based on our viewing history. So whether we realize it or not, deep learning is influencing so many parts of our lives, from the way we communicate and stay entertained to how we interact with technology every day.
And that's why deep learning is such a game changer. Its ability to process vast amounts of data and learn from it has made it essential in building smarter, more intuitive technology. And as these models continue to evolve, we're only going to see more innovative applications that will push the boundaries of what's possible. It's exciting to think about what's next and how much more integrated AI will become in our lives.
All right, let's get into how deep learning actually works, starting with the basics. Deep learning relies on structures called neural networks. These networks are loosely inspired by the way the human brain processes information. Imagine a neural network as a collection of layers. Each layer consists of a set of nodes, or neurons, that are interconnected. When data enters a neural network, it flows through these layers, with each layer processing the information in a unique way. This layered structure is what allows deep learning models to recognize complex patterns. The more layers a network has, the deeper it is, which is where the term deep learning comes from.
That's right, James. And to put it simply, each layer in a neural network has a specific role. Imagine we're training a deep learning model to recognize animals in photos. The first layer might look at very basic features, like edges or colors. The next layer might start recognizing shapes, like circles or lines. As the data moves deeper into the network, each layer combines what it learned from the previous layer to form more complex features. Eventually, after passing through all the layers, the network can identify whether the image contains a cat, dog, or bird based on those patterns.
That's a great way to explain it, Ethan. So let's try to bring it down even further with an analogy. Think of a neural network as a chef preparing a complex dish. The first layer, or ingredient prep layer, might start by washing and chopping vegetables. The next layer might combine those ingredients in a pot, and another layer might adjust the heat and stir. Each layer builds on the work of the previous one, until finally, you have a complete dish. In the same way, neural networks build up layers of understanding by combining simpler patterns to eventually recognize complex objects or make decisions.
I like that analogy. And another thing to understand is how the network learns over time. Neural networks start off with no knowledge. They essentially make random guesses at first. But during training, they're fed tons of labeled data, for example, thousands of images of cats and dogs. The network adjusts its weights, or internal parameters, to improve its guesses based on the feedback it gets after each round of training. It's like a student improving by reviewing the answers they got wrong and figuring out why. With enough practice, the network gets pretty good at recognizing patterns and making accurate predictions.
That's spot on, Ethan. And this learning process is what makes deep learning so powerful. The more data and training it has, the better it becomes. This is why deep learning can handle such a wide range of complex tasks, from understanding speech to predicting outcomes. The layers and adjustments allow the model to make incredibly precise distinctions, like telling the difference between subtle facial expressions or distinguishing between very similar objects.
Exactly. And what's also fascinating is that these networks don't require us to define every little rule or feature manually. Instead, they learn from experience, which means they can even adapt to new scenarios. For instance, a deep learning model that has been trained to recognize cats in various environments might still be able to recognize a cat in a completely new setting, because it's learned the core patterns of what makes a cat, well, a cat.
That's what's so incredible about deep learning. It's not just about recognizing objects or sounds, it's about enabling machines to make complex decisions based on patterns they've learned. This flexibility and adaptability are what make deep learning such a transformative technology. Now let's talk about some of the exciting recent developments in deep learning. One of the most talked about advancements has been ChatGPT, which uses deep learning to generate human-like responses in text. ChatGPT and similar models have transformed the way we interact with AI. They're being used for customer service, content creation, even helping people brainstorm ideas. Another major area is autonomous driving. Companies like Tesla and Waymo are using deep learning to train cars to understand their surroundings, detect obstacles, and make split-second driving decisions. Deep learning has really pushed forward what these technologies are capable of, and they're only getting more accurate and reliable as they process more data.
Absolutely, James. And what's really exciting is the potential for these technologies to continue evolving. Take ChatGPT, for example. It's already impressive, but researchers are constantly finding ways to improve its understanding and creativity. Imagine a future where AI chat models are even better at understanding context and emotions, making them even more helpful for personal assistance or mental health support. As for autonomous driving, deep learning models are advancing to a point where they might not only detect and react to situations, but also predict potential hazards before they happen. This could make autonomous driving far safer than human driving.
That's a great point, Ethan. And we're also seeing deep learning's impact in healthcare, with models that can detect diseases in medical images faster and more accurately than ever before. This technology is helping doctors catch conditions earlier and make more precise diagnoses. It's amazing to think about how much further these advancements can go and the positive impact they could have on our lives.
Exactly, the potential is huge. And as these deep learning models continue to evolve, we're likely to see breakthroughs we can't even imagine yet. It's a really exciting time to be exploring AI and deep learning, and I think we're just scratching the surface of what's possible.
Of course, while deep learning has immense potential, it also comes with some serious ethical concerns. One of the biggest is data privacy. Deep learning models rely on massive amounts of data to learn effectively, and often, this includes sensitive personal information. Think about AI models that analyze healthcare data or track online activity. There's always a risk that this data could be misused, leading to privacy breaches or even manipulation. So, as we develop and use these technologies, it's crucial to consider how we're protecting people's information and ensuring their privacy.
Absolutely, James. And beyond privacy, there are some technical challenges too. Deep learning models require huge amounts of data and computational power to train effectively. Gathering and storing enough high-quality data can be difficult and costly, and training these models often requires advanced hardware like GPUs or cloud-based systems, which can be expensive and energy-intensive. This can limit who has access to developing these models, making it hard for smaller companies or researchers to compete. Addressing these challenges will be key to making deep learning more accessible and sustainable as the field grows.
As we look to the future, the possibilities for deep learning are incredibly exciting. We're likely to see it become even more integrated into our daily lives, tackling complex problems that once seemed out of reach. I think one of the most interesting areas will be making AI models more efficient, so they don't need as much data or computational power. This could make deep learning technology more accessible and allow it to be used in a wider range of industries, from small businesses to healthcare.
Absolutely, James. And deep learning could really make a difference in emerging areas like personalized medicine. Imagine AI models that can analyze a person's unique genetic information and medical history to create customized treatment plans. We're also seeing potential for deep learning to transform education, where it could be used to develop personalized learning experiences, tailoring content to each student's needs and learning style. These are just a few examples, but I think we're going to see deep learning open up countless new possibilities across fields we haven't even considered yet.
It's truly an exciting time for AI and deep learning, and it's inspiring to think about how these advancements could improve lives. I'm looking forward to seeing how these technologies evolve and the positive impact they can have on society.
Same here, James. The future of deep learning holds so much potential, and we're just at the beginning of what's possible.
Well, that brings us to the end of today's episode. We covered a lot, from understanding what deep learning is and how it works, to exploring its current advancements, ethical concerns, and the exciting future possibilities. A big thank you to Ethan for joining me as co-host and sharing his insights.
Thanks for having me, James. It was great to dive into such a fascinating topic.
And to our listeners, thank you for tuning in to the AI Learning Podcast. We'll be back soon with more episodes that explore the latest in AI and machine learning. If you enjoyed this episode, please like, share, and subscribe to stay updated on our upcoming content. See you next time.